Welcome to the DTH series in computer science, and in the series this is a course on artificial intelligence, and in this course we are in unit 5 now, which is natural language processing, a part of it. And in this natural language processing we are in the second portion of NLP, which is semantics. Last class we saw about syntax, and this class we will be seeing the semantics, which is a continuation of the syntax, where we would be doing about the meaning behind the statements. So, if you look at this diagram, it looks the same as the last time, and again I copied it so that we know where we are. So, if you look at the picture, this belongs to the word level, and this the sentence structure last time we saw it is through the parse tree, and today we will be seeing this portion, which is the semantic side, where we would be dealing with the word meanings and how to understand the meanings through a sentence computationally. But there are certain limitations again in semantics, which we will be seeing it today. And fourth will be the pragmatics, which will be very difficult, but nevertheless we would be attempting in this course to address certain part of the pragmatics also. Now, in the last class I gave you a question of drawing CFG, a context free grammar, using context free grammar, draw a parse tree for this statement. I saw a man with a telescope. So, we would do this first and then get into the semantic portion of it. So, if you look at it, this S I can identify as it goes to NP and VP. NP can go to determinant, noun, or it can be a simple noun itself. A prepositional phrase, it can be a preposition or a noun. Along preposition and a noun constitute a prepositional phrase. A verb phrase can be a verb with noun phrase, or a verb phrase itself along with it a prepositional phrase. So, these are the 4 rules, the context free rules that we can use in order to draw this parse tree for the statement. So, it goes like this: S goes to NP and VP, and NP goes to N, which is going to be I. Here VP goes to VP and a prepositional phrase, and this VP goes to again a verb and a noun phrase. A noun phrase can have a determiner and a noun. The prepositional phrase can have a preposition and NP, which can have a noun phrase, preposition noun, or it can also have preposition noun phrase. So, if you see, I saw a man with, this can be determiner, noun, a telescope. So, if you see the structure of the sentence, it says I saw a man with a telescope. So, the man, I saw the man is having a telescope, that is the meaning. Instead, this saw can also be attached with this telescope, where the parse tree would be entirely different. So, you could write the other parse tree separately such that it has 2 different meanings as such. Okay. So, the syntactic tree can solve this kind of interpretation. The 2 interpretation can be addressed by this CFG. Now, coming into the semantics portion of it, the syntactic side towards the left, it addresses the syntax, structure of it, the grammatical sense of it, whereas the semantics will address the meaning of the sentence. And the syntax will just work with only the rules that we give, like for example the context free grammar. If you see the last example, we gave the 4 rules, and with those 4 rules it is going to check whether it is a sentence or not, that is it. But with semantics we can work out the interpretation, what does that say about the sentence as such, and is there a relation between a subject and object through the verb. So, those kind of information can be done with the semantic portion of it. Say, suppose you take this example, which is a common example given in NLP: colorless green ideas sleep furiously. This actually, it is syntactically it is correct, but semantically it is not correct. It does not have any meaning to it. There is no colorless green ideas. Green is actually a color, but when you give colorless green, we do not have any meaning to it. And green ideas with respect to colorless green ideas does not have any sense. And why does those sleep? Only the organisms sleep or humans sleep. So, how do they sleep? Again we do not know. Furiously, it is just an adjective or adverb. So, it does not make any sense to this statement as such, except but syntactically this is correct, but semantically it is wrong. It does not make any meaning. So, how do we address this semantic structure computationally is what we are going to see in this session. So, the semantics, what we will do in this session is to address the word level first. At the word level, how can it contribute to a meaning, and then the relation between the word. When we say a sentence, we have a finite number of words in a sentence. So, within a sentence, are there any relationship between it? That we will address through this portion, and then this will constitute towards the sentence meaning of in that. And when we see the sentence meaning, it may also represent the ambiguous nature of it. So, can we identify the ambiguity computationally, or is it going to be difficult? That we will see in today's class. And computationally, how do we represent it? And again we have the Python tool with NLTK can be used in one sense, but not altogether to represent the ambiguity. So, we will see some representation of it practically using semantics in NLTK as well as the other way around, and then some of the applications we will see. And following that, if time permits, we will also get into the statistical side of NLP. Now, we will look at the first level, which is at the word meaning. At the word meaning, we call it as the lexical semantics. So, here it just describes how the study carry the meaning and how their meanings relate to one another. Say, here is there are many lexical words coming like this, which is going to be which end with YME. The first one will be very much familiar. It is called as synonymy, that is 2 words which have similar or nearly identical meanings, that you would all have learned it in smaller classes also. What are the synonym and antonyms? Antonyms is just the opposites. Synonym would have a meaning, a correlation with each other. So, example is big and large, both are relatively same. They sometimes we use it one instead of the other. The other one is antonym, which have the opposite meanings, that is hot, cold. So, these all whatever I am explaining here comes at the first level, which is at the word level. We call it as a lexical semantics. Third one is the hyponymy, where the word represents a specific instance of a broad category. For example, if you have a flower and rose here, rose is a type of flower. So, at the broader end we call this as hypernym, which I will be giving in the next slide, and at this level is the hyponym. Continuing from there, this is the hyponym, again the same example I have given, so that there is a continuation. So, another example here is vehicle and car. Vehicle is the hypernym, and within vehicle is the hyponym called car. This is the general category, this is the specific category, car is the specific one. Polysemy, it is a single word that have multiple meanings. For example, mouth of a person and mouth of a river, both are entirely different. Homonymy, a same word that has completely unrelated meaning. Example, bat, which is the animal, bat which is used in sports. So, these portions, the words that appears in the sentences, how can we identify it semantically? How can we identify the meaning? Suppose we say the mouth of a river or mouth of Narmada. Mouth of Narmada can be that Narmada can be a river also, or it can be also a female. So, how do we identify that portion of it? Okay, so that is actually that is addressed by the semantic side. The next portion is the compositional semantics, which is the meaning of a sentence that derives from its parts. We have the combined meaning to form the sentence. Say for example, the cat chased the mouse. Here we will take the chased, always the verb, as the predicate structure, the immediate structure, and within this we have the cat and mouse, where cat stands for subject and mouse stands for the object. So, this composition, the meaning of all the three, the study of how words carry and how they relate with each other, this forms the compositional semantics, and one of the way in which we represent this I will be giving in the next slide. Now, before going into the predicate logic structure, we will see the thematic roles also as one of the semantic representation of the meaning. So, here every event involves some kind of a participants. Again, I will explain this through an example. You consider this statement: the chef cut the vegetables with a knife. Here the chef, vegetable, knife, these are going to be the noun portion. The cut is an action. So, how do we identify that? A chef is identified as an agent, the action is cut, vegetables are the patient are the recipient side, instrument is the knife. So, the idea is this kind of a structure through agent, action, patient and instrument, we can construct many different sentence structures that follow the rule. So, through this semantically we can capture the meaning. Another example here is Mary gave John a book. Again, this is a very common example that is given in the natural language processing, and if you see, the agent is Mary, the recipient is John, and what is given is a book which is called as a theme, and what is the action here? It is the gave. So, through these agent, recipient, theme or agent, action, patient, instrument, we can form certain rules such that the sentence structures can be captured according to these structures of agents, actions, or that involve some participants. Now, we will see the predicate logic side of how we can capture the semantics. Say take for example, John runs. Here the run, the statement within that as a run is a predicate, and this we have already done in unit 2, which comes under the reasoning portion, and John is the argument. And similarly, Mary likes pizza, always the verb comes as a predicate with two arguments as Mary and pizza. Every student studies for all x, if x is a student then x studies. So, this captured with the quantitative information also. Some student passed, there exists some student who passed. So, this represent, using these we can capture the quantitative information, the meaning associated with it. And as I said earlier, these are again used in the unit 2 as well as in unit 3, where we did frames or ontology, we use this extensively. Now, coming to the ambiguous nature of the statements. So, there are many problems with the language structure where the first portion either can be lexical or the structural ambiguity. For example, the lexical ambiguity, this is again, I deposited money in the bank, and here also the fisherman sat on the bank. Both there is a bank, the bank is involved in both the statement, but the meaning is entirely different, the first as well as the second, where the first is representing the financial transaction, the second is representing the river bank. This is on the river bank, this is the bank with respect to the finance side. So, how do we identify such ambiguous nature? The structural similarity, I saw the man with the telescope, possible meaning, this is the one we used for the example today as a question. Possible meaning is I used a telescope to see the man, or the man had a telescope and I saw that man who has a telescope. So, these two can, this is a structural similarity, and thanks to syntax, it can syntactic CFG, it can identify this interpretation. And this kind of interpretation we can identify it through the probabilistic measure, through the statistical measure, where it will involve the context. So, we will identify whether this bank is identified as a financial transaction, again based on some probability measure, or in the recent days through LLM we can identify. Now, another one would be the word sense disambiguation, where the goal is determine the intended meaning of the particular word in the specific context. For example, he sat on the bank of river, she went to bank to deposit money, again the same example that we are taking with respect to the bank. So, again as I said earlier, the context defines the meaning. The context is one with respect to the finance, this is with respect to the river, and this is with respect to the finance. So, we have to identify the context, and based on it we can see which bank does the context belong to, or does the statement belong to. So, here is a small representation of the semantic side in Python. Where if you see, I will make it a little bit bigger, where the first one we would see the lexical similarity here, where at the first line I have imported NLTK, which is a natural language toolkit, and here I am downloading WordNet. WordNet is essential for the lexical similarity portion, where we saw the synonym, antonym, hypernym, homonym, all those stuff are described in this WordNet. And there are multiple corpus available in NLTK, and we will import that corpus, and from the corpus we will import the WordNet, and as WN is, it is for the short form that we write in Python. Suppose the word is car, we want to identify for this car what is the synonym, what is the definition, what are the examples for each of it, and what are the hypernyms. So, that is given by SYN dot name, that SYN is coming from the synsets. Yes, this is for syn, this is in synsets. Synsets again is apart from the WordNet side. WordNet we are importing as WN. So, WN dot synsets of the word which is car. So, for car we are trying to get from NLTK what is the synonym, what are the examples for it, and what is the hypernym. So, you could see the output is car, it is a wheeled vehicle adapted to the rails of railroad, which is given from the NLTK. The examples are 3 cars had jumped the rails. The hypernym is wheeled vehicle. So, this is the output of NLTK for the lexical semantics. Now, to represent as subject verb object, again this is a simple Python representation, where we are giving the first example is boy eat apple. For that the output is we are giving this function as take always the verb and put the subject and object in order. So, this has got nothing to do with NLTK, this is our representation of giving verb and then subject and object. So, in the first case it is going to be eat boy apple, the second example it is going to be chase dog ball. So, this represents boy eats apple, dog chases ball. So, this is an example of the practical implementation of the semantics, the small representation of it. Now, before moving into the next module, I will give you the question that to be answered for this module is list the possible application of semantics that are available in the current scenario, where all you can use this kind of representation, especially the practical example that I have shown, where can you use it. So, this answer we will be seeing in the next class. Now, we will see the limitations of the semantics. I have told you some of the ambiguities. So, we will see more limitations of the semantics in the language side. This is the first limitation. Again, here I am listing only a few of it. One is lack of context awareness. For example, can you pass the salt please? What does the statement actually mean? Pass the salt, is it pass or fail, or can you pass the salt, can you give the salt please? So, thus pass the salt, it has how can you identify this structure? This is very difficult. Difficulty handling ambiguity, again we saw multiple examples there, bat and a bank. So, that has a limitation with respect to the semantics. And third, it cannot fully understand the pragmatics. For example, if someone says it is very cold in here, and are they asking me to close the door, close the window so that it is cold, or are they giving the information? So, those kind of pragmatic, the practical meaning that is with reference to the context or with reference to the surroundings, that is very difficult to understand. And challenges with figurative language, for example, hi, hello, and the emotions, emoticon that we see nowadays. So, those languages it is very difficult to identify. And world knowledge is required, again whatever we see in India it may not be the same in the other countries. So, those kind of slang that is to be adopted, and how do we identify that, how do we identify the meaning behind it, again that is going to be difficult. Then the computational complexity behind all this, behind understanding the language, it is a very big task. Now, some of the limitations we can address it through the statistical side or the probability sides. So, if we see generally the language is going to be ambiguous, that we saw so far, and it is variable, it is whatever we say in English is not adaptable to Tamil or any other language, and it is context dependent. As we see, it is with respect bank with respect to the river, or bank with respect to the financial sector, and the language is noisy. There will be many similar very unwanted things that we have to remove off in order to understand. And while humans handle all this effortlessly, we just understand what the other person speaks, but machines do not. So, how do we make them learn? Again we need to data perspective approach, because machines are good at crunching data. So, what we need to do is put all the language in some form in numbers, so that a machine can process those. So, through that we are getting into the next shift known as the statistical NLP. But before moving into the statistical side, we will see a quick overview of how NLP was there from the initial to the current stage. So, during 1950s to 1980s, there were the linguistic rule, like what we saw in the syntactic side, the CFG grammar and all that, the grammars, the dictionaries, and then from 1990s to 2010, it is the statistical NLP side, where we went into the probability model, which will be doing it in the next session, and I will give you a quick introduction now. And then the machine learning side, and because the machine learning was fast approaching during 2000, the statistical NLP picked up during that stage, and because of which we have a large site corpus. Corpus is a huge data that is available on the internet, and then this is the latest trend, which is the neural NLP, or the deep learning perspective of the natural language processing, which works on the basis of neural networks towards the transformers and right now we have the large language models. So, we could see 3 shifts. The first one was rule based NLP, the second is statistical, and the third is the deep learning approach. Now, we will be going into the statistical NLP in the next session, but here is a quick introduction of the statistical NLP, where the language exhibits some patterns, and these patterns, this is the presumption with which the statistical side can be approached. Say for example, strong T is common, but powerful T, it is grammatically correct, but normally it is not used. So, how do we identify that? One way is to understand through the data. So, how many times strong T comes and how many times powerful T comes in the set of documents, and say that okay, strong T is only valid and powerful T is not correct. So, we will take a simple probability example now and work out. Suppose we want to predict the next word, like I would like a cup of dash. So, what the dash would be? These are the possible words that the machine can identify. One is tea, second is coffee, third is water, fourth is pencil. For these, ideally the answer according to a human being would be either tea or coffee, but to a machine what we would do is statistically we would give a large corpus of data, and we will give some algorithm to compute the probability at the end. And at the end of the probability, suppose we have the probability like this: the tea has 0.45, coffee has 0.35, water has 0.15, and pencil has very less probability, is 0.0001. So, ideally which has the most probability? It is 0.15. So, the probable word is selected. So, this is the basis with which the statistical model, this is a very simple example, but we will go through a few other examples where the algorithmically how the NLP task would operate. Now, the summary of this module, where first we learnt about the semantic structure starting from the words that include the lexical side like the antonym, synonym, hypernym, polynym and mononym. The compositional variety, where the structure of the word can be represented in terms of the verb and the noun phrases. For example, dog chased the ball can be represented as chased with dog and ball. And we also looked at multiple ambiguities and how it can be represented, but we could not answer it completely. Some of it we could answer it in the future classes, where we will deal with the statistical side and LLM side. And we also saw a quick implementation of semantics through NLTK, which was with the lexical side. And I also gave a brief introduction to statistical NLP with the 3 historical shifts. So, in the next session we will be dealing with the statistical side of NLP in detail.